Join us as we dive into a profound discussion on consciousness, quantum mechanics, and artificial intelligence, featuring three brilliant minds: Sir Roger Penrose, Federico Fagan, and Bernardo Kastrup. This video unpacks the fascinating dialogue between these esteemed thinkers, exploring the nature of consciousness, its link to quantum mechanics, and the implications for artificial intelligence. We'll highlight areas of agreement and profound divergence, offering you a unique perspective on these complex topics. A foundational agreement between Penrose and Fagan is that consciousness cannot be computed. A computational system, like a computer, will never truly be intelligent or conscious. Penrose asserts that understanding is not a computation. He views AI, a term he considers a misnomer, as merely manipulating symbols without true understanding. The real danger, he warns, isn't AI surpassing us, but deceiving us into believing it's conscious, leading us to underestimate human uniqueness. Kastrup corroborates, likening AI to a simulation. He states, simulating a black hole on your computer doesn't make you get sucked into it. He sees AI as a simulation of human behavior, trained on human data, but lacking any actual inner experience. Fagan defines humans by their inner semantic and experiential life, which he posits resides in a quantum field, not just the physical body. In contrast, AI operates on syntax symbols, but lacks genuine experience or meaning, which is semantics. Penrose proposes that consciousness involves quantum effects within the microtubules of the human brain. This idea emerged from his collaboration with Stuart Hameroff, aligning with Penrose's long-held belief that human understanding transcends formal systems. He believes certain mathematical problems have no computable solution. He arrived at the idea after communicating with Stuart Hameroff, who introduced him to the notion of microtubules as a potential site for quantum effects. Penrose argues that current quantum theory is, quote, incomplete and not even totally correct because it fails to explain wave function collapse. He posits that collapse is an objective physical process, independent of consciousness, stemming from the incompatibility between quantum superposition and Einstein's equivalence principle of general relativity. Federico Fagan offers a distinct perspective. For him, consciousness and free will are not emergent properties, but fundamental, self-evident postulates. Fagan argues that the very quantum fields themselves are consciousness. He posits that the collapse of the wave function is not an external cause, but rather consciousness itself expressing itself, a free will decision of a field. Fagan contends that the existence of consciousness and free will explains the, quote, crazy properties of quantum physics, such as the no-cloning theorem. Qualia, or internal perceptual experiences, are represented by quantum information, being private and non-clonable. Bernardo Kastrup, while aligning with Fagan on many points, presents a unique take on wave function collapse. For him, it doesn't really happen, in an objective, ontological sense. Kastrup views collapse as an epistemic transition, a shift from an idea about what we expect to see to an observation of what actually happens. It's a change in our knowledge or expectation, not an event in reality. He argues that the wave function is a, quote, model of knowledge, not something ontologically real. The dichotomy of consciousness causing collapse or collapse leading to consciousness, he believes, presupposes the wave function's ontological reality, which he questions. Despite their agreements, Penrose, Fagan, and Kastrup profoundly diverge on the nature of wave function collapse and the precise role of consciousness within it. For Penrose, collapse is an objective physical event. It arises from the incompatibility between quantum mechanics and general relativity, occurring when superpositions become, quote, large enough, potentially measurable in experiments within a decade. Fagan sees collapse as a direct manifestation of the free will and intrinsic consciousness of quantum fields themselves. For him, consciousness is fundamental, not an emergent property. Kastrup argues that collapse is merely a change in our knowledge or expectation, an epistemic transition rather than an ontological event. The wave function is a model of our knowledge, not reality itself. This insightful discussion highlights that consciousness may indeed be fundamental to understanding physics, whether as an emergent property of physical processes, a primordial postulate shaping quantum reality, or an epistemic transition in our comprehension. The journey to understanding continues.